So piecewise functions come up quite a bit in real-life situations. So one example of this would be if a company gives you a discount when you buy more items. So a lot of times you'll have a situation where you're printing signs, let's say, for a club. And what will happen is a company is going to charge you $1.25 for each of those colored copies up to the first 100. But for every sign over 100, they're going to charge you 75 cents. So if you buy more of them, you get a bulk discount. This is going to be an example that will require a piecewise function. So we're going to call this function C of S. So it is going to be the cost as a function of the number of signs. And notice that is a function because if you buy a certain number of signs, you will only get charged one cost. So in order to figure out what this is going to look like, let's start by just picking values of S. What if you buy 0 signs? How much is the company going to charge you? 0. If you buy 1 sign, they will charge you $1.25. 2 signs would be $2.50, and so on. They'll keep charging you an extra $1.25 for every single sign up to 100. So if you were to buy 100 signs, you would pay $125. They are $1.25 each. You buy 100 of them. But notice it's going to change now. So now for every sign over 100, they're only going to charge you 75 cents. So this would be $125.75. And the next one would be $126.50. And so on forever. So on a graph, let's think about what this is going to look like. So you have 0, 0. And then you're going to go up by $1.25 per sign until you get to 100. So your slope on this would be over 1, up 1.25. So for every sign, so remember this is the number of signs on the S-axis, and this is the cost in dollars. So for every sign, you get charged an extra $1.25. However, once you hit past 100, notice now it's only going up by 75 cents, so the line is less steep. So now, if you go over 1, you're only going up 0.75. And the place where it changes is right there in the middle, at the point 100, 125. So we can see in the graph, this is a piecewise function. It's 2 linear graphs. You have a linear graph up to 100, and you have a different linear graph after 100. So what we want to do is we want to try to write the equation. So let's start by writing the equation of the first part of the graph. So notice it has a y-intercept of 0 and a slope of 1.25. So it's going to be 1.25s, make sure you use the right variable, plus 0, and you don't need the plus 0. But this is only going to work for signs between 0 and up to 100. So the yellow portion of the graph there is a linear function, 1.25s, and it's restricted from 0 to 100, including 0 and including 100. The second part of the graph now, that has a slope of 0.75. The problem is we can't tell what the y-intercept is back there. So let's remember from Algebra 1 how we find a y-intercept. So if we have a slope and we have some point, we can find the y-intercept. So we have a point, 100, 125, and we have a slope of 0.75. So we have y equals mx plus b. So 125 equals 75 plus b, which means b is 50. And that's going to be valid when the number of signs is greater than 100. There is no upper limit on this. It doesn't say you can only buy up to 500 signs or anything like that, so this goes on forever. Notice there's an arrow on the graph. So coming up with the piecewise function is certainly a little more challenging, but I want you to at least see how we could think through that, how we can take a real-life situation and try to build a function that would work. So now if I wanted to know how much would you pay for 300 signs, you would simply plug 300 into the bottom piece of that function. So let's take a look at one more example. So notice this one, it already gives us the graph. So we are being given a function C of P. That is the cost of a hotel room for P people. So the hotel charges $85 a night for a hotel room with up to 2 people. So notice on the graph, it is $85 up to 2 people. But then they charge an additional $15 for every person after that, up to 6. So notice now the cost goes up $15 for each additional person up to 6. And then it stops. So to find the function, we need to break this up into its 2 parts. So notice we have a horizontal line. So the equation of this horizontal line will just be 85. And that's whenever the number of people is between 0 and 2. The trickier part is the second piece. So I can see that the restriction is going to be 2 up to 6. But I need to find the equation of that. Well, I know that the slope is going to be $15 per person. But I need to know the y-intercept. Now, in this case, it would probably be faster to just subtract $15 twice, because if it's a slope of 15, it's going to go down 15, down 15 more. But if you want to, you can also solve it like we did previously. We have a point on the graph that would be 2, 85, and we know that this slope is over 1 up 15. So you can do y equals mx plus b and you get that your y-intercept would be 55. So if you were to continue that line back, you can see that 55 looks like a pretty good approximation for that. So now that we have the function as an equation and we have the graph, we can now evaluate this function using either. I personally like to use the equation because then I don't have to try to approximate things or to make guesses. So C of 1 is between 0 and 2. So C of 1 is 85. 3 is between 2 and 6. So this will be 15 times 3 plus 55. 45 plus 55 is 100. 7 is not on either of these domains. 7 is too big. So C of 7 is undefined. And if you think about that in the context, they charge $15 per person with a maximum capacity of 6 people. So if you go to that hotel and say, I would like a room for 7 people, how much do I pay? They will tell you to leave. Or they will tell you to get 2 rooms. One of the two. So that is how we work with piecewise functions, in context and out of context.